It's now time to take a quiz over what you learned today. So, question number 1, name a type of energy. Okay, so we talked about what? Chemical, electrical, light energy. Okay, then there was thermal energy, mechanical energy, and then nuclear energy. Question number 2. What is the potential energy of a 100 Newton weight 2 meters above the floor? So what variables are you given in the problem and what are you looking for? So we're going to say 100 newtons equals, and then over here we're going to have 2 meters equals, and then here we're going to have question mark equals. So 100 newtons is a unit of force. Meters is a unit of distance. So that would be the height. And then we're looking for energy, but it's potential energy, so put a P on it. All right, now what equation is going to connect the variables? Now this is kind of tricky. So the equation is going to be potential energy is going to be equal to mg and then the height. So I think that you can see here's the potential energy, here's the height, but we can't solve the problem because we don't know the force. Or do we? Well, do you remember that mg, that's weight. M times gravity is going to be the weight of the object. That's the force. It's the force of gravity that's pulling down. So yes, we can solve the problem. So this thing here, that's the F times H. So let's plug in. So we're going to say 100 and then times 2 is going to be 200, and then what unit? So it's energy, so put down a J for joule. So 200 joules of energy. Question number 3, can a bullet have more kinetic energy than a car, and explain why? So we need to know what's the formula for kinetic energy. Okay, so let me erase this. You're still there, right? You haven't left me. Okay. I'd hate to be doing this for nothing. So this time we're going to say energy kinetic is 1/2 mv squared. So m is going to be the mass, and then v is going to be the speed. So how can a dinky bullet, so we're going to put a small m, so a bullet has very small mass, have more kinetic energy than a car? So a car has a big M. Well, if the V is big enough, then when you square the velocity of the bullet and you multiply it by the mass of the bullet, it could have more energy than a big car that is traveling at a very small speed. So, and if it's not moving at all, so V is equal to 0, then 0 times anything is 0. So that big car could have a kinetic energy of 0. Question number 4. How much work is done holding a 100 Newton weight stationary 2 meters above the floor? So come up with your answer while I'm erasing. All right. Okay, what is the formula for work? So it's asking how much work is done. So work is going to be equal to force multiplied by distance. Okay, but it says that it is stationary, so it's not moving. Now you do have a tremendous amount of force here, but it didn't once it's stationary, it's not moving anymore. So the distance that it's moving is going to be 0. So even though it's 2 meters above the floor, it took a lot of energy to raise it that 2 meters. So that would be the force multiplied by the 2 meters. But once it's up there, it's not moving anymore. So therefore, 0 movement times anything is going to be 0. So it's going to take 0 work to hold it up there. Now, on a microscopic view, you know that it takes work up there once you're holding it, because your arms are going to start to shake. Okay, that's because the muscles that are holding it up there are twitching teeny tiny distances. So in each one of your muscle fibers, there's a force acting on it, and they're moving tiny distances as they're trembling, and so that's work. So your muscles are producing energy in order to hold that thing up there. But we're talking about macroscopic work, and it would be 0. So let's go to number 5. A ball is held a certain distance above the floor. What type of energy does it have? Potential. So it has potential energy, mgh. The ball is then dropped. What type of energy does it have just before it hits the floor? It's moving, so it's got kinetic energy. Now it says just before it hits the floor, so how high off the floor is it? 0. So how much potential energy does it have? 0. So all the potential energy, no kinetic, because it was in your hand before you dropped it. So no kinetic, it was all potential. When it just before it hits the floor, it's all kinetic and no potential. How does the magnitude of the energy compare up here versus down here? Samey same. So they both have the same energy. And that energy that it had just before it hits the floor will be turned into heat and sound when it hits. Number 6, name 2 ways to reduce the power that a device uses. Okay, so it says to use the formula for power in order to guide your thinking. So can you write down the formula for power? Okay, the formula for power is going to be P is going to be equal to the energy that you put into the system divided by the amount of time. So if you want to reduce the power, you could reduce the E somehow. So if you made the E smaller, then the P would be smaller. So what's the other thing you could do? Okay, increase the amount of time that it's doing it in. So if you increase the T, that would reduce the P, or if you reduce the E, that would reduce the P. Number 7, what does a machine do? So a machine can increase the amount of force that you apply. So you put in a certain amount of force, and then what comes out of the machine could be a greater force. Or a machine can increase distance. So you put in a small distance into the machine, and a large distance comes out of the machine. But it can't do them both at the same time. So it can't increase the force and the distance. Number 8, what would happen if these 2 people sat on the following teeter-totter? Okay, we're going to say, let's put in the amount of work on this side over here. So that's going to be 200 times 2 meters. So that's going to be 400, and they would be joules. So 400 joules of energy. Now let's look at what's happening on the other side. So the other side is going to be 100 and then multiplied by 5. And so this one over here is going to be 500 joules of energy. So what's going to happen? So since this side over here on this side is, it's going to apply more torque, which means that this side over here is going to fall down in comparison to this side over here. So that person on that side is going to go up into the air, and then this person is going to go down on that side. Now, it's not in equilibrium. So in order to put it into equilibrium and then be able to say that F times R equals F times R, the person that's on this side over here is going to have to move in a little bit closer. And you could calculate that. So you could calculate how close would that person have to be in order to do that. Okay, so that's our review for this lesson. So in our next lesson, we are going to learn all about rotational motion. See you then.